July 6th. On the surface, it really just feels like another summer day. But if you dig into math history, it's actually one of the absolute most magical dates on the calendar. Welcome to this explainer. Following the script structure outlined in the source document titled ENG Vol, we're going to see exactly why this date is so special. Across different centuries and completely different countries, brilliant minds who happen to share this exact date on their tombstones or birth certificates literally built the hidden patterns of our modern world.
Here's a quick look at our timeline for today. We're looking at four incredible minds. Alfred Kempe, born in 1849, Georg Simon Ohm, who died in 1854, Agnes Wells, passing in 1959, and Ronald Graham in 2020.
Okay, have you ever actually stopped to wonder why your phone charges so incredibly fast and, well, safely without catching fire? I mean, really think about it. How does the raw electricity just waiting in your wall outlet know exactly how much power to send through that tiny little cable to your delicate phone battery without completely frying it?
Section 1. Georg Simon Ohm. Died July 6, 1854.
So Ohm solved this massive, invisible puzzle for us. He figured out the exact mathematical rules connecting how hard electricity pushes, which, we call voltage, and how fast it actually flows, which is the current. It's kind of like water in a pipe, right? Voltage is the water pressure, and current is the actual amount of water flowing through. By turning that relationship into strict math, he gave us Ohm's law, making literally all of our modern electronics safe to use.
The huge takeaway here is this. Every single device you own is secretly playing by Ohm's rules. Whether you're plugging in a giant refrigerator or just hopping up your smartwatch, you are relying right now on the math he formalized way back in the 1800s.
Still on July 6th, let's jump back a bit on our timeline to the year 1849. That's the birth year of Alfred Kempe.
Think about opening up Google Maps. How do computers know exactly how to color millions of pixels on those digital maps without the borders of different countries or states just bleeding into each other? How does it instantly separate thousands of distinct regions in just a fraction of a second?
Section 2. Alfred Kempe. Born July 6, 1849.
Well, Kempe tackled this massive mapping mystery using geometry. He worked on something called the Four Color Theorem, and he introduced two game-changing concepts: unavoidability, which basically means certain patterns absolutely have to appear in any map, and reducibility, meaning really complex map sections can be boiled down to smaller, simpler ones. Now, sure, his original proof had a tiny flaw, but those exact two ideas became the ultimate foundation for computers to finally solve the map coloring problem a whole century later.
So why does this actually matter to us? Well, because the math Kempe used to color maps is literally how computers see our world today. His brilliant logic is the exact reason your screens can organize incredibly complex graphics instantly without missing a single beat.
Moving forward on our timeline, we arrive at July 6, 1959, the day we lost Agnes Wells. Have you ever pointed one of those stargazing apps up at the night sky and wondered how it perfectly maps out the entire moving universe right there on your tiny smartphone screen? Like, how does it know exactly where every single star is located at this very second?
Section 3. Agnes Wells. Died July 6, 1959.
Agnes meticulously calculated the exact motions, the radial velocities, and the speeds of 150 different stars in the Pleiades cluster. But honestly, what's truly inspiring is her double legacy. While she was literally mapping out the heavens, she was simultaneously this fierce leader down here on Earth, serving as a dean of women and fighting relentlessly for equal rights and educational access for female students. Talk about a powerhouse.
She used math to reach for the stars, and she absolutely made space for others to follow. Her rigorous dedication to tracking our place in the universe gave us the baseline data that makes modern astronomical tracking, like those incredible apps on your phone, even possible today.
Finally, checking our timeline one last time, we arrive at July 6th, 2020, to remember Ronald Graham.
Think about the sheer chaos of the internet for a second. Why does WhatsApp or Facebook seem to know exactly who you're connected to? How do they figure out your suggested friends, mapping out these weird relationships through friends of friends in literally a fraction of a second?
Section 4. Ronald Graham. Died July 6, 2020.
Graham pioneered ways to measure how everything connects in massive networks using something called graph theory. He even inspired a famous game called the Erdos number. It's basically the math world's version of 6 Degrees of Kevin Bacon. It tracks how every scientist is socially linked to one another through their published work. He basically proved that no matter how vast or chaotic a network gets, the connections can always be mapped.
So here's the crazy part. Every single time you connect with a friend online, you are quite literally walking on his mathematical web. Graham helped us realize that our entire digital world, all of our messy, complicated human relationships, is really just one big, beautifully connected mathematical graph.
So, looking back at our timeline one last time, Kempe, Ohm, Wells, and Graham, 4 incredibly brilliant people, all connected by a single day in history.
Every person we've talked about in today's explainer, across all these different centuries and countries, they all ask the exact same fundamental question. How do we find the pattern hiding inside the chaos?
And because they had the sheer courage and the curiosity to actually ask that question, we get to enjoy a world completely filled with amazing, invisible technology. From perfectly safe wall outlets and colorful digital maps to universe trackers in our pockets and complex social networks, it's all built directly on their discoveries.
So, the next time you look at the calendar, just remember that one single date can hold the secrets to our entire digital lives. If July 6th brought us all of this, where's the math going to take us tomorrow? And what